Now in this video, we're going to answer the following question. Solve the following inequality. And we've been given the inequality 2 divided by x squared minus 1 is greater than 1. If you find this video helpful, please consider leaving a like, a comment, sharing this video, and subscribing to our channel for more content like this. An equation tells us the value of something, but an inequality tells us what it could be. Instead of giving us an exact value with an equal sign, it uses symbols like greater than, less than, or not equal to indicate how two values compare to each other. When we solve an inequality, we use the same basic algebra moves that we would for a regular equation. The big difference is that instead of finding one exact number for the answer, we usually find that there are a set of possible values that make the statement true. Answering this question is a 5-step process. First, we need to subtract 1 from both sides, giving us an expression on the left, that by finding a common denominator, we can express as a single fraction equal to 0. Then by equating the numerator to 0 and solving, and equating the denominator to 0 and solving, we get a broad range of values for x that when substituted into the inequality determine whether it has a positive or negative value. We've been given the inequality 2 divided by x squared minus 1 greater than 1. Solving a non-linear fractional inequality requires a careful systematic approach. We cannot simply cross-multiply by the variable denominator because we don't know if that denominator is positive or negative, which affects the inequality sign. Instead, we need to analyze the sign of the entire fraction using critical points. To begin, we need to subtract 1 from both sides, giving us 2 divided by x squared minus 1 greater than 0. By replacing 1 as a fraction with a numerator and denominator of x squared minus 1, we can rewrite the left side of the inequality as 2 minus x squared minus 1 divided by x squared minus 1 greater than 0. We can tidy this up by expanding the bracket and simplifying the numerator to get 3 minus x squared divided by x squared minus 1 greater than 0. Setting the numerator equal to 0 gives us 3 minus x squared equal to 0. Adding x squared to both sides gives us x squared equal to 3. So x is equal to plus or minus root 3. And setting the denominator equal to 0 gives us x squared minus 1 equal to 0. Adding 1 to both sides gives us x squared equal to 1. So x is equal to plus or minus 1. These critical values give us 5 sets of values for x that we need to consider separately. First, when x is less than minus root 3, x is greater than minus root 3 and less than minus 1, x is greater than minus 1 and less than 1, x is greater than 1 and less than root 3, and when x is greater than root 3. The expression has no value when the denominator is equal to 0. Hence, we don't consider values of x equal to plus or minus 1 for that reason. Substituting values within each range into the expression 2 divided by x squared minus 1 minus 1 and evaluating the solution, we can determine which sets of values give us a positive or a negative solution. When x is less than minus root 3, the answer is negative. When x is between minus root 3 and minus 1, the answer is positive. When x is between minus 1 and 1, the answer is negative. When x is between 1 and root 3, the answer is positive. And finally, when x is greater than root 3, the answer is negative. The solutions are the values where we get a positive answer. That gives us solutions in the range minus root 3 and minus 1 and 1 and root 3. As an extension to this question, why do we use less than signs instead of less than or equal to signs? Drop your answer in the comments. So the solution to this inequality and the answer to this question are values of x between minus root 3 and minus 1 and 1 and root 3. If you found this video useful, please consider leaving a like, a comment, and subscribing to our channel. Thank you.